to a video dealing with word problems, specifically translating words into algebra. Again, this is the difficult stuff of algebra, taking a context or a problem or a bunch of words and trying to make meaning of all of it, understand the problem, and then rewrite the whole thing in the language of algebra using all symbols and variables and letters and such not. And it's tricky, it's hard. So hopefully this example helps give you some understanding about some ways to approach it, helps you see some ways to actually get to the algebraic equation that you can solve. Okay, so my problem is the difference of 3 times a number and 10 is the quotient of twice a number and 5. And I'm asked to find what is that unknown number. Well, there's 4 key things we want to look for, especially in word problems like this. We like to keep our eyes out for the words sum, difference, product, and quotient. Because those all have meaning in terms of adding, that's what sum is, difference is subtraction, product is multiplication, and quotient is division. So if I'm translating words into symbols, then I need to look for those key words. So what do we see here? We have the difference, all right? I got some subtraction going on. I'm going to write a little subtraction symbol above there just to help me realize that's subtraction. 3, I like the letter 3. That's something I can rewrite as a number. 3 times a number and 10. 10 is easy to translate. Is the quotient, quotient means I got division, of twice a number and 5. We'll talk about what that twice number means here in a second. But there we go. We just took an initial pass at some things we can start to turn into symbols. We also have things that we're trying to find, right? Any good algebra problem, there's something unknown I'm trying to solve. We're trying to solve for what is that number? Well, let's let our variable n equal the unknown number. So anytime in here where I see a number or unknown number, I'm going to rewrite that as, well, that's my variable n. And 10 is the quotient of twice a number and 5. All right, there's still some other things I want to look for. If this isn't something I can solve, there should be an equal sign. So we're looking for the words is equal to, or sometimes it just is like, or is equal to, or is. In this case, the difference of 3 times a number and 10 is, right there, there's the is, that's my equal sign. That is this, the quotient of twice the number and 5. The only last thing to deal with here is this twice a number. And if you think about twice your age, or twice as much pizza, or twice as much of anything, that involves just multiplying by 2. So when I see twice a number, well, that means 2 times. I would put a little 2 times. So it doesn't say product necessarily. It doesn't even say multiply. It doesn't even say times. But when I see twice a number, well, that means I have 2 times that number. Okay, let's start to put this out. There's also the keywords and. We've talked before, but whenever I have sum, difference, product, or quotient, whenever I have these operations, they involve 2 things. The sum of one thing and another, the difference of 2 things, the product of one thing and another. So the word and helps me see, okay, the difference of, what am I taking the difference of? 3 times a number and 10. So when I see that, well, the difference, so subtraction of 3 times a number and 10. That's how I'm going to translate that. So there's my difference. It's not the difference of 3 and a number. The 3 times a number go together. That and helps me know where the difference goes to. Is, I'm put my equal sign. The quotient, all right, so I got division of 2 things. What am I dividing? Let's look for that word and. So I'm dividing twice a number and 5. So twice a number and dividing 5. And there we go. We've just set up our equation. Got some division, got some multiplication, got some subtraction. The only thing we're missing is addition on this one. But let's go ahead and solve it out. We're asked to find what's the number. Working with fractions, my strategy, what I always love to do is I always love to multiply both sides just to remove all fractions. It helps me keep an exact answer all the way to the end. So I'm focusing in on this 2 divided by 5. I'm going to multiply everything by 5 on both sides. I got to make sure I multiply everything. So on the right side, 2n divided by 5, but then also multiplied by 5, those just cancel each other out. They're opposite operations, so they undo each other, leaving just 2 times n. I like that. But on the left side, I'm going to use the distributive property. 5 times 3n is going to be 15n minus 5 times 10 is going to be 50. Make sure you multiply everything on both sides when you do this process. Okay, same equation, but now no fractions. It's going to be a little bit easier to work with. All right, I need to get 1n by itself, so I'm going to subtract 2n from both sides. Leaves just 0 on the right, and now I've got 13n minus 50. Now I want to get that n all by itself, so I'm going to add 50 to both sides. Subtract 50 plus 50, those go to 0. So now we're at 13 times my unknown number has to equal 50. My final step is, I'm going to move it up here. I've got 13n equals 50. I'm going to divide both sides by that 13 to see that n equals 50 thirteenths. I can change that into a mixed number. 13 goes into 50 3 times. 3 times 13 is 39, which means there's 11 left over from the 39 to get the 50. And I'm still dividing by 13. So there's my exact answer. My unknown number should be 3 and 11 thirteenths. Hopefully that was helpful though. Again, in working, the hardest part of this problem was just translating it out and getting the right equation to actually start off with. Once I'm there, then I can just run through my distributive properties, doing things, getting that variable by itself. But hopefully that was a helpful exercise for you guys.